Hello and welcome. In this video we're going to look at something called SSH host keys. And what this is a concept of how SSH servers identify themselves. So we've already done a video on user keys so that we can have, our users prove who they are when they're trying to connect to a server. But we also need to make sure when they connect to a server, they're actually reaching the machine they think they are. This way, this will help us keep our networks a bit more secure, stop people from stealing our data, or at least make it harder to do so. So a common type of attack is ARP poisoning, sometimes called DNS spoofing, man in the middle. In just plain English, it's somebody is impersonating one of your machines. They can redirect traffic to a destination under their control, make it look like you're connecting to the machine you thought you were. So there's a message on the left side of the slide here where, you get this big warning, possible spoofing detected, remote host identification is changed. This could be an indication that somebody has done something like this to your network. But it might not be. There are some perfectly reasonable explanations for why this might show up that I'll discuss in a minute. If you see something like this, you absolutely do not ignore it. You investigate it further. You find out why this happened. And if there is a perfectly reasonable, logical explanation, perfectly innocent, okay, I'll show you how to deal with that. But if it does appear, you can't find a reasonable explanation for why this is happening in your network, it probably means your network is under attack, and you should definitely be getting your security admins involved. So we'll switch over to my virtual machine here, and I'm going to SSH to demo 2. Now I undid some things I did in the past explicitly so we could see this message. The first time I try to connect to this machine, demo 2 at 192.168.122.2, we can't be certain of its authenticity. We haven't talked to it before. So it's providing us this SSH fingerprint, this unique identifier to say this is this machine. And it's prompting us, are you sure you want to connect to this machine? Well, in this case, I know that really is my demo 2, so I'm going to say yes, and that's going to make this machine store that fingerprint in a file we'll see in a minute. It permanently added it to its list of known hosts. I put in my password. And I'm connected, and I run some commands, do whatever it is that I need to do, disconnect, and maybe the next day I go back to connect again. Because this machine now has that unique fingerprint from the other machine, it doesn't prompt for it again. It already has it, and when the other machine sends it, it can compare them and say, this is the same fingerprint. I really am talking to demo 2, so I just do my login as normal. Great. However, I'm going to pause for a second and go off screen, and I'm not actually attacking my network, but I'm causing a situation that will look like I am. So I'll be right back. And I'm back. So in that little break there that I paused the video so you won't have noticed any time elapsed, I went into my network and I changed some things around to, imitate one of these spoofing man-in-the-middle attacks. So when I try to connect to demo 2, we're going to get a warning. There we go. Not quite the same message that was on the slide. It does change over times, but we're getting this warning. The remote host identification is changed. we tried to connect to the machine that we think is demo 2, the thing that is responding at 192.168.122.22, but the fingerprint that that machine provided was different from the one that we recorded in the past, from the previous times we connected to it. So it's warning us this doesn't look right. So contact your system administrator. Well, we are the system administrator, so this is our job to sort out. Now, this could be somebody performing one of these man-in-the-middle attacks, spoofing our machine and trying to get people to log in and provide passwords to it. Or a way that this can actually end up just organically happening in your network. If you reinstall a machine, it generates a new SSH fingerprint for this. So if I had just, something went horribly, horribly wrong with my demo 2 machine and the backups failed, or, well, maybe some of them didn't fail, maybe some of the data was there, but I had to actually reinstall the operating system. When I did that, it would generate a new, unique SSH fingerprint. So the next time I connect to it, I would see a message like this. So, yeah, if we haven't just done something like that, absolutely, bring this to the attention of your senior administrator, bring it up to your security admins. They need to deal with this because somebody is attacking your network. But if we have just reinstalled this machine, well, we can go to this known hosts file and remove the old key. This is even telling us on a user-by-user basis, this gets stored in the home directory, that hidden .ssh directory, known hosts. So let's take a look at that. And here are these unique keys, the ones from demo 2. So I'm just going to get rid of those. And then the next time I try to connect, because I've just reinstalled my demo 2, we go back to that original message. I can't authenticate this machine. I can't be sure of it because I don't have any fingerprints for it. Are you sure you want to copy down this fingerprint? In this case, yes, because I know what caused this. It is safe for me to do this. And that's that. Wait, gave a bad signature in libcrypto. Oh, actually, I kind of revealed what I did there. So it looks like there is a distinction between how CentOS 8 and CentOS 9 handles this, and where'd that go? It kind of reveals what I did. In the background, in that pause, I turned off my actual demo 2, turned on my C8 demo machine, and just gave it the IP address that demo 2 is supposed to have. So I imitated another machine. And yeah, it looks like there's a difference in how some of those cryptographic keys are handled between those releases of the operating system or the SSH packages on them. I will have to explore that a bit more outside of the video. Regardless, this key is still working the way it was supposed to work. So what we've looked at in this lesson is just a quick examination of how SSH servers identify themselves. They have that unique SSH fingerprint that when you try to connect to them, they provide. And we saw, if this information is incorrect, how we can delete the old incorrect one and allow the machine to copy the new one. Doing this is going to, again, like most of the rest of these videos on SSH, it will help keep your network secure, because now we can be sure when we try to SSH to another machine, it really is that machine. Thank you. and I'll see you in the next video.